So now, this is kind of the main part of a voltage doubler. We got a little more to talk about. But in case, we got 5 volts at the supply right there. We're going to look at the capacitor voltage. It's going to go down because we have a rectifier diode. And current's going through that 1000 ohm resistor. And just a little bit of current. But again, that was enough to keep the voltage down. Now we got a trickle of current going through the rectifier diode. So it's raising the capacitor voltage a little bit. But in case, we got about 4.4 volts we can expect the capacitor to charge to because of the 0.6 volt drop. But that's coming to the negative supply. Now, if we switch it to the positive supply, part of the voltage doubler, now you can see we got double the voltage. Of course, a load is going to drop this quickly. You want to pump it into a capacitor where it cannot be discharged out of that capacitor. So we're going to need another diode and capacitor. But this is the basic principle for voltage doubling. So now, we measured the voltage of the positive side of the capacitor in relationship to ground in the previous short there. We started off basically with this situation right there. The capacitor is going to charge through that rectifier diode. So it is going to leak current, but for the most part, we're going to get 4.4 volts. Again, it's going to go up as current leaks through. When you draw current from it, that's all you're going to get is 4.4 volts. But in case, that charges the capacitor. We have this switch where we can move the jumper to the positive 5 volt supply. So what happens when we do that? Remember, the voltage here is in relationship to ground because current cannot go back through that diode. But we go up to the 5 volts there. And again, this is headed to ground. So we got the 4.4 volts that this was charged to plus the 5 volt difference that is being applied at first if no current is being drawn. So that's going to pump up the voltage to about 9.4 volts. Basically a voltage doubler. So now, last couple of shorts, we looked at how we can go through that diode to charge that capacitor to about 4.4 volts or whatever. Then we move the jumper to the positive supply. That's going to add to the voltage of the capacitor. We're going to get about 9.5 volts approximately at that point. Now we have a second diode coming down here to this capacitor to capture that charge. But we're going to have a diode drop. So out of that 9.5, it's going to lower it to below 9 right there, maximum voltage. But in any case, we got this capacitor. That diode will help it capture charge. This resistor right there is just stopping too much current from going into the capacitor, giving a release valve. As their diodes have leakage, so they do let a little bit of current through. But in any case, now we're going to pump this up, and you're going to see that we don't get right to about 9 volts. We got to charge it and pump it a bunch of times because we just kind of get the voltage difference. That capacitor starts discharging, its voltage goes down, but that one charges, its voltage goes up. So now here's the schematic diagram. When we got the jumper to ground there, the capacitor charges like that. Gets to about 4.4 volts out of 5 because you got the diode drop. But yeah, we got that path there. Then we move the jumper to the positive supply. So that pushes current in this direction into the other capacitor, but through a diode. So you do get a diode drop again. But in case, once this voltage gets to about that voltage minus the diode drop, then current stops flowing. So this voltage is going to go down while that one goes up. So we got to keep repeating the process. We go to the negative supply to charge that capacitor, go to the positive supply to pump current into the other one until this one gets to about 9 volts, about 0.5 or 0.6 volts. Less than this one can get to because we have the diode drop. Of course, if you have a load, you got to do that really quickly to keep this topped off because the load is going to draw current as well.